Hello everyone, and welcome to NJIT Math Club's video tutorial on cross product. So before we get into how to do cross product, we need to figure out what is cross product. Well, very simply put, the cross product of two vectors is a third vector that is perpendicular to both vectors. Now, the most simple version of this would be, in this situation, the vector in the positive y direction, the vector in the positive x direction, and the vector in the positive z direction. The cross product of the x and y vectors is the z vector, because it's perpendicular to both, and the vector that's the cross product of the y and z vectors is the x vector, and so on and so forth. So, how do we find the cross product? Well, very simply, it is the determinant of both vectors. And if you don't know what a determinant is, it's okay. You don't need to know it on how to do this. So, for example, if you have two vectors, vector A, which equals AI, AJ, and AK, and vector B, which equals BI, BJ, and BK. And to get that, to get the cross product of it, would be to find the determinant of A. So for this determinant, we will do it across the top line. So that would be I times, it would be I times AJ, AK, BJ, BK, because that's the part of it that is not including the vertical and horizontal I, minus J, AI, AK, BI, BK, plus K, AI, AJ, BI, BJ. Okay, which would eventually reduce down into AJ, BK, minus AKBJ I plus AKBI minus AIBKJ plus K plus AIBJ minus AJBI. K. Okay, so that's the basics of how you could get it. Now, especially if you don't know what determinant is, this might seem a little bit complicated. So, luckily for you, you don't need to know the nitty-gritty of all of this. You can just do it simply by looking at them and, well, finding cross. So I'm going to get rid of this and then show you how to do it in a way without knowing really what determinants are. Okay, now the very easy way to do this without even knowing what determinants are is to take crosses. So what do I mean by that? Well, if you want to find the resultant vector in the I direction, you would cross the two things in the j and k direction, which would be cross down All right, so this would be the result of A cross B. So, as you can see, for the I vector, for the I part of the vector, it would be aj bk minus ak bj. And you would do that by getting the determinant of these two columns and these two rows, which, if you don't have to think about it that much, you can just do aj bk minus bj ak. That's easy to remember for me because it's a cross, and you're doing cross product. And you do the same thing for j. J is these two columns because they're the ones without j, and these two rows because they're the rows that you're finding it of. So it would be ak bi minus bk ai. And same thing with the k part of the vector. ai bj, aj bi. There. It looks a bit off, but it works. And to do that, I will show you that by proving it. All right. So to prove that A cross B is perpendicular to both A and B, I'm going to show you the dot product between each of these vectors and A cross B. Okay, so this is the dot product between A and A cross B, simplified a bit more, and let's take a look at it. AI, AJ, AK, minus AI, AJ, BK. Those factor out. Negative AI, AK, BJ, AI, AK, BJ. Those factor out. AJ, AK, BI, AJ, AK, BI. Okay, that equals 0. So when the dot product between two vectors is 0, that means they are perpendicular. Now let's take a look at it with B. Okay, so I've done the liberty of reducing B dot A cross B, and now we're going to look at this. So there's AJ, BI, BK, AK, BI, BJ, negative here, positive here, and AI, BJ, BK, and AI, BJ, BK. So now you can see that both B and A are perpendicular to A cross B. So this is why cross product is so useful. It's all about finding this perpendicular vector, which you can do a lot of stuff with. One of my favorite ways is just finding the shortest distance. It's much easier to find the shortest distance of something between a line and a point if you can find the vector that is perpendicular to the line. And you can do projections and other things that make it much easier than trying to think about it in any other way, especially with cosines and sines. It's much simpler and I like it more. All right, so that was our video on cross product. Hope you guys enjoy this. If you have any questions, put it down in the comments, and I'll see you guys later. Take care.